Okay, so hi everyone. So today in this video we are going to solve this problem from the CSES problem set that comes under the sliding window section and goes by the name sliding window OR. So let us start with this problem now. So the problem reads like this, that you are given an array of n integers and your task is to calculate the bitwise OR of each window of k elements from left to right. So in this problem the input data is large and it is created using a generator. So in the input the first line contains two integers n and k, that is the number of elements and the size of each window, and the next line contains four integers x, a, b and c, that is the input generator parameters. The input is generated as follows. So the first element of the array is equal to this x and the remaining elements are generated using this function here. So in the output we have to print the XOR of all the window ORs. So this is our constraints here. As you can see that the value of k and n can go up till 10 to the power 7. The value of x, a and b can go up till 10 to the power 9, and the value of c can also go up till 10 to the power 9. So this is a given input here and this is the expected output and this is the explanation here. So the question is asking us a simple thing, that we have to take the XOR of all the window ORs, right? So for each window we have to calculate its bitwise OR, and then out of all those bitwise ORs we have to take the XOR of all those ORs with each other and simply print that digit at the end. So it is similar to the questions that we have solved in the past in this playlist, like the sliding window sum and the sliding window XOR, right? So here instead of calculating sum or XOR you have to calculate the OR of each window now. So how we will solve this problem? So to understand better, here I have considered example by myself. So in this example there are a total of n elements, that is 11 elements originally present in the array. So since I want to use one based indexing, so that's why here I have added a dummy value at the 0th index here, as you can see, and the size of each window here is 3. So we know that in order to calculate the total number of windows we use this formula, that is n minus k plus 1. So here it will be 11 minus 3 plus 1, that is 8 plus 1, that is 9. So a total of 9 windows are present here of size 3, and for each such window we want to calculate its bitwise OR, and at the last we have to take the XOR of all such bitwise ORs and finally print the answer that we will get after taking the XOR of all such bitwise ORs. Right, so we will play with this example only in order to understand better. So let us now move forward and see what approach we will apply. Right, so what I will do is I will simply calculate the prefix OR and suffix OR of the array, but not for the whole array, but rather for blocks of size k. So what does this statement mean here? Let's see. So we know that we are given with this array originally, right? So we are given with this array here having a total of 11 elements originally from 1 to 11, and this is the dummy index. So what now I am telling you to do is you have to divide this array here starting from 1 going till 11 into blocks, and each block will have a size of the window, that is k. So since our k is 3 here for this example that I have considered, so now what I am telling you is to divide this array into size of k, that is this will be our first block having a size of 3, this will be our second block having a size of 3, this will be our third block having a size of 3, and after this, since there are no more greater than 3 elements are left, so whatever the number of elements are left that is less than 3 will become a part of our last block, that is block D, right? So in this way I have divided the given array here into 4 blocks, as you can see, and the last block is not completely filled. So this is how we will start with this approach, that is dividing the original given array into blocks of size k here. But the thing is that how we will make use of this in order to find the bitwise OR of each window. So let's see that. So now since I have told you that we have to calculate the prefix OR and the suffix OR for each block here, right? So since this is our given array and now we have divided it into different blocks, right? So now I want to calculate the prefix OR for each block. So what does that mean? So let's see that. So since now we know that this is our first block, this is our second block, this is our third block, and this is our fourth block. So now for this I want to calculate the prefix OR, right? And this is the prefix OR calculated only. So this is our original given array here, and using this I have calculated the prefix OR. That is, what I have done here is for block A here, I have calculated the prefix OR. That is, for the first index here, it will be equal to the bitwise OR of all elements starting from index 1 and going till index 1, which will be equal to nothing but 4. So here I have written 4. Now for the second index in this block, it will consist of the bitwise OR of all the elements starting from 1 and going till 2 here, like this. That is 4 or 6, which will be nothing but 6. So here I have written 6. And similarly for the third index here, I have written the bitwise OR of all the elements starting from 1 and going till this third. That is the last element of this block. That is 4 or 6 or 2, which will be nothing but 6 only. So here I have written 6. So in this way I have computed the prefix OR of the block A here. But since I have told you that we will calculate this prefix OR but not for the whole array but rather for each block separately. So it means that now we don't have to propagate this result into the next block. Rather than we will again start it fresh from the next block. That is, since this is our next block and this is the original element value which is 1. So again I will take the bitwise OR starting from this index 4 and going till this index 4 only. That is this. So here I have written 1. And now when I want to compute the prefix OR for the fifth index, so it means that I want to calculate the prefix OR starting from this fourth index and going till this fifth index. That is 1 or 2. So 1 or 2 will be nothing but 3 only. So here I have written 3. And similarly, when I want to calculate the prefix OR for the sixth index, then it will be the bitwise OR of these 3 elements only and not any previous element. So this is what I am trying to tell. That is 1 or 2 or 7, which will be equal to nothing but 7 because all the bits for 7 are set. So it is equal to 7 now. So in this way I have calculated the prefix OR for the block B as well. Now I am standing on the 7th index here and I want to do the same thing. So for the 7th index it will be equal to 3 only because the bitwise OR starting from this and going till this will be equal to 3 only. But for the 8th index it will be equal to the bitwise OR of these two, that is 3 or 1, which will be equal to nothing but 3. So here I have written 3. And finally for the 9th index it will be equal to the bitwise OR of these 3 elements, that is 3 or 1 or 9, which will be equal to nothing but 11. So here I have written 11. And in this way our block C is also done. That is, we have successfully calculated the prefix OR for this block C. Now finally I will move to block D, and now I want to calculate the prefix OR for this element. So again it will be equal to nothing but the prefix OR is starting from this and going till this only, that is 8. So it will remain equal to 8. And finally we will be moving to the next index or the last index, that is the 11th index, and it will be equal to nothing but the bitwise OR of these two elements, that is starting from the first element of this fourth block and going till the current index, that is this. So 8 or 2, which will be equal to nothing but 10. So here I have written 10. And in this way our fourth block is also completed. That is, we have successfully calculated the prefix OR for the fourth block now. So I hope that you have understood what we have done here. So what we have done here is very simple, that since this was our original given array, so here I have calculated the prefix OR for different blocks. So for each block here, as you can see that for each block the first element is equal to the actual element of the array only, right? So 4 1 3 8. So 4 1 3 8. And why this happened? Because we are not using any previous result of the previous block, because we want to start our calculation fresh from this block now. So that's why whenever the prefix or result was calculated for a block, then for the next block we started it very fresh. That is, we used the original elements value so that the result can be calculated separately for this block, and similarly for this block and this block, right? So this is how we will calculate the prefix OR, right? So I hope that you have understood this, and in the very similar manner we will also calculate its suffix OR. That is, since we have started our calculation in prefix OR from the first index and went in this direction, now in the suffix OR we will do the opposite. That is, since this is our original given array, right? So let me copy this so that you can understand it better, right? So this is our array here, right? So keep this in mind, this is our array, and now using this array we want to calculate the suffix OR. So we will start from the last index and we'll go till the first index like this. So again, since the array is divided into 4 different blocks, so I want to calculate suffix OR for each of these 4 blocks now, right? So I will start from the last index, and since this is equal to 2, so it will remain equal to 2. That is, we will take the bitwise OR starting from this and going till this only, so which will be equal to 2 only. Now if I want to calculate the value of suffix OR for the 10th index here, so it will be equal to the bitwise OR of this 2 with this 8, that is 2 or 8, which will be equal to nothing but 10. So here I have written 10, and in this way our fourth block is completed here, or the first block from this side. Right, now we will enter this block, and when we will enter this block, then again this 9 will remain equal to 9 here, because the bitwise OR will start from this and will go till this only. But for this 8th index, the bitwise OR will comprise of these two elements, and for this index the bitwise OR will comprise of these two elements. Right, so that's why 9 or 1 will be our suffix OR of 8, which will be equal to nothing but 9 only. Similarly, the bitwise OR of these three elements will be equal to the suffix OR of the 7th index, which will be nothing but 11. And in this way our this block is also completed. And don't forget that we are moving in this direction, that is we are taking the bitwise OR of elements like this. So earlier we are taking it like this for the prefix, and now we are taking it in opposite direction. So now since this element value is 7, so we will start from here and we'll go till here only. So 7 OR will be equal to 7 only. So here I have written 7, and then I will move forward, and to calculate the suffix OR of the 5th index, I will take the bitwise OR of these two elements, that is 7 or 2, which will be nothing but 7 only. And similarly, to calculate the suffix OR of the 4th index, I will take the bitwise OR of these three elements, that is 7 or 2 or 1, which will be equal to nothing but 7 only. So in this way our this block is also completed now, and we will enter this block. So now I want to calculate the suffix OR values for these three remaining indexes. So again this element will remain as it is, that is 2, and I want to calculate the suffix OR value for this second index, which will be equal to nothing but the bitwise OR of these two elements, because I am moving in this direction, that is 2 or 6, which will be equal to nothing but 6 only. And finally I will move to this first index, and I want to calculate the suffix OR of this first index, that is the bitwise OR of these three elements in this direction. So 2 or 6 or 4, which will be equal to nothing but 6 only. So in this way I can say that our prefix OR array and suffix OR array is calculated. And now I am very sure that you must have understood that what these two arrays here actually mean, right? That is what values they hold. So now since we have calculated these two arrays here, now our task is done. That is, now if someone asks us to print the bitwise OR of each window, then these two arrays will help us in order to calculate that. So let us see how it will do it. So now since we know that this will be our very first window, right? That is the last element of the first window will be k equal to 3. That is the index of the first window of the last element will be k equal to 3, and we have to slide it till the last index, that is n. So our first window is from 1 to 3, so that's why we will start our iteration from this k equal to 3 till this n, right? So now what I'm saying is, if I modulo k is equal to 0, so since our I is starting from 3 and going till n, so if this is equal to 0, so it means that the current index that I'm standing on is nothing but the last element of a block, right? So since here initially k value is equal to 3, so 3 modulo k, that is 3 modulo 3, will be nothing but 0 only. So this statement will be true, and it means that I'm standing on the last element of the block. And if I'm standing on the last element of the block, then what does it mean? It means that I want to calculate the bitwise OR of this window, right? That is the bitwise OR of this, and we know that very well that the bitwise OR of this window is stored in nothing but the prefix OR of this index, that is the prefix OR of this 3, because we know that the prefix OR of this third index contains the bitwise OR of these three elements, right? Because this is how we have made it. Because the prefix OR of 1 consisted of the bitwise OR of this, and the prefix OR of 2 consisted of the bitwise OR of this, and the prefix OR of 3 consisted of the bitwise OR of these three elements, right? So that's why the prefix OR of this third consists of the bitwise OR of these three elements here. So that's why whenever we will be standing on the last element of each block of size k, then just by using this condition we will know that we are standing on the last element. So we just have to print the prefix OR of I, because it contains the bitwise OR of each and every element of that window that on which I am standing on. So we just have to print this prefix OR of I, which we have already calculated, right? But if it is not the case, so suppose that now I'm standing on the 5th index here. So if I'm standing on the 5th index here, then please pay attention now. So if I'm standing on the 5th index now, so we know that since the window size is 3, so now my window should be looking like this, right? That is starting from 3 and going till 5. So now I want to calculate the bitwise OR of this window, that is 2 or 1 or 2. right? So how we will do this? So we are dividing this into two parts. This is our first part and this is our second part, right? So if we know the bitwise OR of this part and the bitwise OR of this part, then simply by taking the bitwise OR of these two parts will give us the bitwise OR of this part, that is from 3 to 5. That is the window that we require now, right? So ask yourself that do we now know the bitwise OR of this part and the bitwise OR of this part now? Yes, we know this, because the bitwise OR of this part will be nothing but the prefix OR of this 5, right? So this was our original given array. So that's why if now I want the bitwise OR of this part, then it is nothing but the prefix OR of 5, right? So if you see the prefix OR of this 5, then it is equal to 3, which is nothing but the bitwise OR of these two elements. So we know the bitwise OR of this part. And do we also know the bitwise OR of this part? Yes, we know this. So if you go to the suffix OR of this 3, so suffix OR of 3, then it is equal to 2, which is nothing but the bitwise OR starting from this index and going till this index only. So you know the result also, that is equal to 2 only. So now you know the result of the first part and the second part, that is the bitwise OR of this part and the bitwise OR of this part. So now if you just take the OR of these two parts, then don't you get the bitwise OR of this part? Yes, you definitely get it. So that's why whenever we are in the else condition, so we just have to take the bitwise OR of these both parts, that is prefix OR of I, that is this, and the suffix OR of I minus k plus 1, that is this. So this formula inside, that is I minus k plus 1, will adjust how many elements we have to take from the previous window. So if we were standing on the 4th index, then we will be taking the prefix OR of I here, that is just this element, but here now we need to take two elements. So I minus k plus 1, that is 4 minus 3 plus 1, that is 1 plus 1, that is 2. So 2. So in this way we would be taking suffix OR of 2, which will be nothing but the bitwise OR of these two elements. And this way we will be calculating the bitwise OR of this part and this part if I was our 4, that is this window. And in this way we will be calculating the bitwise OR of each and every window. And since we have to take the XOR of each and every bitwise OR of each window, so we'll be taking it parallelly, and finally we will print that result, right? So what we are doing here is very simple, that whenever we want to calculate the bitwise OR of each window, then if we are present on the last element of each block, then it is equal to nothing but the prefix OR of that index, right? Because it contains the bitwise OR of each and every element of that window. But if we are present in somewhere between, right, then our window will consist of actually two different blocks, that is the current block and the previous block. So some elements will come from the current block and some elements will come from the previous block. So in order to get the bitwise OR of the complete window, we'll be dividing it into two parts, that is first from the previous block and next from the current block, right? So that's why to get the prefix OR of from the current block here, we are just taking a prefix OR of I, that is the prefix OR of this part, and then since one element is left which will come from the previous block, that is we need suffix OR of 3, that is suffix OR of I minus k plus 1, so it will give the bitwise OR of this part, and in this way combined it will give us the bitwise OR of this that we need, and we will simply take a XOR of it with the existing result. So this is the whole logic here. So now if I make you see the code here, so this will be our code. So first I have taken the inputs of n and k, then 4 integers here, and then here I have taken the input of the array in one based indexing, and here I have declared two arrays here, prefix OR and suffix OR, in one based type only, right? So using this here I have calculated the prefix OR. So the logic is simple, that whenever I will be standing on the first element of each block, then it will be equal to the actual element only, otherwise I will be taking it as a normal prefix OR, that is the OR of current element with the previous result, and in this way our prefix OR is calculated. Similarly I will do the same thing for suffix OR, but this time I will start from the last index and will go till the first index and do a I minus minus. So if I am standing on the last element of each block, which can be defined by this condition, that is I modulo k equal to 0, then it means that the suffix OR value will be equal to the original element value. But if not, then the suffix OR of the current index will be equal to the OR of current element with the suffix OR of the next element, because we are coming from the reverse direction. So this, and in this way our prefix OR array and suffix OR array will be calculated. And now if we want to determine the bitwise OR of each window, so we know that our first window ends at k and we have to go till n, right? So that's why I will check that if the current index on which I'm standing is modulo k equal to 0, then it means that we are standing on the last element of each block, right? So we know that whenever we'll be standing on the last element of each block, then the answer will be nothing but prefix or of I. So we will just take a XOR of it with the existing variable, that is answer, that we have to ultimately print, right? That is, the prefix or of I is the bitwise or of this current window. But if we are not present on the last element, that is, we are present in somewhere between, so it means that the bitwise or will come from the current block as well as the previous block. So the contribution of current block will be equal to prefix or of I, obviously, and from the previous block it will be suffix or of I minus k plus 1. So together it will give us the bitwise or of the window that we need here, and simply we will do a XOR with this answer variable. And after processing all the windows, whatever this answer variable will hold, we will simply print that and return, right? So this is our whole code here, and in this way we will calculate the bitwise or of every window and finally print our result. So yeah, this is the whole logic in this problem. So yeah, this was pretty much about this video. So if you understood this problem, then please consider subscribing the channel and liking this video and share with your friends who need to watch the series, right? And I'm pretty sure that these can be helpful in your contests and interviews. So thank you so much for watching this video. Thank you.